To establish safe procedures for resetting trip breakers or blown fuses to restore electrical power, this procedure applies to all personnel authorized to work on electrical systems. The electrician is responsible for ensuring the safety of all personnel and equipment during electrical work. Authorized personnel are responsible for following established procedures when resetting trip breakers or blown fuses using insulated tools, a non-contact voltage tester, electrical tape, and a replacement fuse if necessary. Before resetting trip breakers, firstly determine the cause of the trip breaker by examining the circuit and connected equipment. Secondly, disconnect non-essential loads from the circuit to reduce current draw. Thirdly, turn off all connected appliances and equipment. When resetting trip breakers, firstly identify the trip breaker on the electrical panel. Secondly, verify that there is no voltage present on the breaker using a non-contact voltage tester. Thirdly, push the trip breaker firmly into the on position. When replacing blown fuses, firstly identify the blown fuse on the electrical panel. Secondly, verify that there is no voltage present on the fuse using a non-contact voltage tester. Thirdly, remove the blown fuse using insulated tools. Fourthly, insert a replacement fuse of the correct amperage and type into the fuse holder. Fifthly, ensure that the fuse is fully seated and tighten the fuse holder. After resetting, firstly turn on connected appliances and equipment one at a time to avoid overloading the circuit. Secondly, observe for any unusual noises, sparks, or smoke. Thirdly, if the breaker trips or fuse blows again, immediately disconnect power and contact an electrician. Always wear appropriate personal protective equipment, including insulated gloves and eye protection. Never attempt to reset a breaker or replace a fuse that is unknown to be tripped or blown. Use only the correct amperage and type of fuse for the circuit. Do not overload circuits by connecting too many appliances or equipment. If you encounter any difficulties or uncertainties, discontinue work and contact an electrician. Record the time, date, circuit, and corrective action taken on a maintenance log. Label replace fuses with the date and amperage for future reference. All authorized personnel must receive training on this safety procedure prior to performing electrical work. Let's delve into the intricacies of electrical safety when dealing with circuit breakers and fuses. It's crucial to approach these tasks with a clear understanding of the potential hazards involved. Firstly, we'll discuss the purpose of these procedures. The primary goal is to establish a standardized and safe method for resetting trip circuit breakers and replacing blown fuses. This ensures that electrical power can be restored efficiently while minimizing the risk of electrical shock, burns, or other injuries. Secondly, the scope of these procedures extends to all personnel who are authorized to work on electrical systems. This includes electricians, maintenance technicians, and any other individuals who have received the necessary training and authorization. It's important that everyone involved understands and adheres to these procedures consistently. Responsibilities are clearly defined to ensure accountability. Electricians bear the responsibility of ensuring the safety of all personnel and equipment during electrical work. This includes conducting thorough inspections, identifying potential hazards, and implementing appropriate safety measures. Authorized personnel are responsible for following established procedures when resetting trip breakers or replacing blown fuses. This includes using the correct tools, wearing appropriate personal protective equipment, and adhering to all safety guidelines. Essential materials for these tasks include insulated tools such as screwdrivers, pliers, and wire strippers. A non-contact voltage tester is crucial for verifying that there is no voltage present before working on any electrical components. The electrical tape is used for insulating wires and connections. Replacement fuses of the correct amperage and type are necessary for replacing blown fuses. The procedures are broken down into three main sections before resetting trip breakers, and replacing blown fuses. Before resetting a trip breaker, it's essential to determine the cause of the trip. This involves examining the circuit and connected equipment for any signs of overload, short circuit, or ground fault. Disconnect any non-essential loads from the circuit to reduce the current draw. Turn off all connected appliances and equipment to prevent a sudden surge of power when the breaker is reset. When resetting a trip breaker, firstly identify the trip breaker on the electrical panel. It will typically be in the OFF or trip position. Secondly, verify that there is no voltage present on the breaker using a non-contact voltage tester. This ensures that it is safe to proceed. Thirdly, push the trip breaker firmly into the OFF position and then push it to the on position. This resets the breaker and restores power to the circuit. When replacing a blown fuse, firstly identify a blown fuse on the electrical panel. It may be discolored or have a broken filament. Secondly, verify that there is no voltage present at the fuse holder using a non-contact voltage tester. Thirdly, remove the blown fuse using insulated tools. Fourthly, insert a replacement fuse of the correct amperage and type into the fuse holder. Fifthly, ensure that the fuse is fully seated and tighten the fuse holder. After resetting a breaker or replacing a fuse, it's important to take precautions. Turn on connected appliances and equipment one at a time to avoid overloading the circuit. Observe for any unusual noises, sparks, or smoke. If the breaker trips or the fuse blows again, immediately disconnect power and contact an electrician. Safety precautions are paramount when working with electricity. Always wear appropriate personal protective equipment, including insulated gloves and eye protection. Never attempt to reset a breaker or replace a fuse if the cause of the trip or blow is unknown. Use only the correct amperage and type of fuse for the circuit. Do not overload circuits by connecting too many appliances or equipment. If you encounter any difficulties or uncertainties, discontinue work and contact an electrician. Documentation is essential for maintaining a safe and reliable electrical system. Record the time, date, circuit, and corrective action taken in a maintenance log. Label replace fuses with the date and amperage for future reference. Training is a critical component of the safety procedure. All authorized personnel must receive thorough training on these procedures before performing any electrical work. This training should cover the identification of hazards, the proper use of tools and equipment, and the correct procedures for resetting breakers and replacing fuses. Let's consider some additional details regarding circuit breakers. Circuit breakers are designed to protect electrical circuits from overcurrents, which can cause overheating, damage to equipment, and even fires. When a circuit breaker trips, it interrupts the flow of electricity to the affected circuit. This is a safety mechanism to prevent further damage. There are several types of circuit breakers, including standard thermal magnetic breakers, ground fault circuit interrupters or GFCIs, and arc fault circuit interrupters or RFCIs. Standard thermal magnetic breakers trip when the current exceeds the breaker's rated amperage. GFCIs are designed to protect against ground faults, which occur when electricity flows through an unintended path to ground. RFCIs are designed to protect against arc faults, which are dangerous electrical discharges that can cause fires. When selecting a replacement circuit breaker, it's crucial to choose one with the correct amperage rating and type for the circuit. Using a breaker with a higher amperage rating than the circuit is designed for can overload the circuit and create a fire hazard. Now let's discuss fuses in more detail. Fuses are another type of overcurrent protection device. They contain a metal filament that melts and breaks the circuit when the current exceeds the fuse's rated amperage. Fuses are typically used in older electrical systems, although they are still found in some modern applications. There are several types of fuses, including cartridge fuses, plug fuses, and time delay fuses. Cartridge fuses are commonly used in appliances and electronic equipment. Plug fuses are typically used in residential electrical panels. Time delay fuses are designed to withstand temporary overloads without blowing. When replacing a blown fuse, it's essential to choose one with the correct amperage rating and type for the circuit. Using a fuse with a higher amperage rating than the circuit is designed for can overload the circuit and create a fire hazard. It's also important to ensure that the fuse is properly seated in the fuse holder. A loose fuse can cause overheating and arcing, which can lead to a fire. Now, let's explore some common causes of trip breakers and blown fuses. Overloads are one of the most common causes. This occurs when too many appliances or equipment are connected to a single circuit, drawing more current than the circuit is designed to handle. Short circuits are another common cause. This occurs when there is a direct connection between two wires in a circuit bypassing the intended load. Ground faults can also cause breakers to trip or fuses to blow. This occurs when electricity flows through an unintended path to ground, such as through a person's body. Arc faults can also cause breakers to trip. These are dangerous electrical discharges that can occur when there is a loose connection or damaged insulation in a circuit. To prevent trip breakers and blown fuses, it's important to avoid overloading circuits. This can be achieved by distributing the load across multiple circuits or by using appliances and equipment that draw less current. It's also important to inspect electrical cords and equipment regularly for damage. Damaged cords and equipment can create short circuits, ground faults, and arc faults. If you notice any signs of electrical problems, such as flickering light, sparking outlets, or burning smells, it's important to contact an electrician immediately. These problems can indicate a serious electrical hazard. Let's discuss some additional safety tips for working with electricity. Always turn off the power at the main electrical panel before working on any electrical circuits or equipment. Use insulated tools and wear appropriate personal protective equipment, such as insulated gloves and eye protection. Never work on electrical circuits or equipment when you are wet or standing in water. Be aware of the location of overhead power lines and maintain a safe distance from them. Never attempt to repair electrical equipment or appliances unless you are qualified to do so. If you are unsure about anything, contact an electrician. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical safety. It's important to be familiar with the NEC requirements for your area. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's updated every 3 years to reflect the latest advancements in electrical technology and safety practices. Specific articles and tables within the NEC address overcurrent protection and safe working practices. For example, NEC Table 310.15b16 provides ampacity ratings for various conductor types and sizes. Article 240 covers overcurrent protection, including circuit breakers and fuses. Article 110 covers general requirements for electrical installations, including safety precautions. When working on electrical systems, it's important to follow lockout-tagout or LOTO procedures to prevent accidental energization of circuits. Lockout-tagout involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Only authorized personnel should be allowed to remove the lock and tag. Regular inspections of electrical systems can help to identify potential hazards and prevent electrical accidents. Inspections should include checking for damaged wiring, loose connections, and overloaded circuits. Thermographic scanning can be used to detect hotspots in electrical equipment, which can indicate a potential fire hazard. Electrical safety is a shared responsibility. Everyone who works with or around electricity should be aware of the potential hazards and take precautions to prevent accidents. By following safe work practices and adhering to established procedures, we can create a safer electrical environment for everyone. Now, let's consider some specific scenarios that you might encounter when resetting breakers or replacing fuses. Suppose you find a trip breaker in your home. Firstly, you should try to determine the cause of the trip. Was there a power surge, or were you using too many appliances on the same circuit? If you can identify the cause, you can take steps to prevent it from happening again. If you can't identify the cause, you should contact an electrician to investigate. Before resetting the breaker, make sure that all appliances and equipment on the circuit are turned off. This will prevent a sudden surge of power when the breaker is reset. When you reset the breaker, push it firmly to the RFF position first and then push it to the on position. If the breaker trips again immediately, don't keep resetting it. There is likely a more serious problem that needs to be addressed by an electrician. Now, suppose you find a blown fuse in your electrical panel. Firstly, make sure that the power is turned off to the circuit before you attempt to replace the fuse. Use a non-contact voltage tester to verify that there is no voltage present at the fuse holder. When you remove the blown fuse, inspect it carefully. If the filament is broken or the fuse is discolored, it's a sign that the fuse was overloaded. When you replace the fuse, make sure that you use a fuse with the correct amperage rating and type for the circuit. Using the wrong fuse can create a fire hazard. After you replace the fuse, turn on the power and test the circuit. If the fuse blows again immediately, don't keep replacing it. There is likely a more serious problem that needs to be addressed by an electrician. Let's discuss some common misconceptions about electrical safety. One common misconception is that electricity is not dangerous if you are careful. While it's true that you can reduce the risk of electrical accidents by being careful, electricity is always a potential hazard. Even low-voltage electricity can be dangerous under certain circumstances. Another common misconception is that you can repair electrical equipment or appliances without any training. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Attempting to repair electrical equipment or appliances without proper training can be dangerous and can create a fire hazard. Another misconception is that ground fault circuit interrupters or GFCIs are only necessary in wet locations. While GFCIs are particularly important in wet locations, they can also provide valuable protection in other areas of the home or workplace. GFCIs are designed to protect against ground faults, which can occur in any electrical circuit. In conclusion, electrical safety is a critical concern that should be taken seriously. By following safe work practices, adhering to established procedures, and seeking professional help when needed, we can minimize the risk of electrical accidents and create a safer electrical environment for everyone. Remember to always prioritize safety when working with electricity, and never hesitate to contact an electrician if you have any questions or concerns. Always respect electricity and treat it with caution. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work or concerns. Electricity can be dangerous, but with proper knowledge and precautions, we can all stay safe. Stay informed, stay alert, and stay safe.